The objective of this lesson is to represent collected data on a line plot. In third grade, students learned that line plots are used to represent measurement data to view smaller amounts of data. This is different from bar graphs or pictographs, which are used to represent categorical data. Here is an example of a line plot. Marigold sprouts were measured at 8 days, and their growth in inches was plotted here. Notice the different parts of a line plot. This includes the title, the scale, the minimum and maximum values, and the plotted data points. From this data, we can gather that a total of 20 plants were measured. Each X on the chart represents one measured marigold plant. We can also quickly note the shortest and tallest plants. The shortest plant measured 1/4 of an inch, and the tallest plant measured 1 1/4 inches. If only marigolds with growth larger than a 1/2 inch could be sold, we can discover the number of plants ready to be sold is 15. Additionally, we can calculate the total plant growth for all plants measured by adding up the measurements for each X on the graph. We can even figure out the average growth for all the measured plants by taking the total growth, 15 inches, and dividing it by the number of plants, 20, for an average growth of 3/4 of an inch. Now let's create our own line plot. To do so, we must first gather measurement data. In this lesson, students measured how fast they could pinch a falling ruler between their fingers and recorded the distance the ruler fell to the nearest 1/8 inch. The data students collected is shown here. To begin creating our line plot, we'll start with an open number line. Looking at our data, the values fall between 2 and 4 inches, so we'll make those measurements the maximum and minimum values on our line plot. Since the data was measured to the nearest 1/8 inch, we use that as the scale for our line plot. Let's begin by placing 3 inches halfway between 2 inches and 4 inches. Then we can add 2.5 and 3.5 inches. From here we can add our marks for each 1/4 and each 1/8 of an inch. Our next step is to plot out X's for each measurement in our data set. Let's begin with the first given value of 2 3/8 inches and place an X on the corresponding location of our line plot. We will follow the same process for the remaining data. 2 1/4 inches, 3 inches, 2.5 inches, 3 1/8 inches, 2 7/8 inches, 2.5 inches, 2 3/4 inches, 2 1/4 inches, 2 3/4 inches, 2.5 inches, 2 7/8 inches. Our line plot is complete. We can now identify the smallest and largest measurements as 2 1/4 inches and 3 1/8 inches. We can spot the most frequent measurement as 2 1/2 inches and the least frequent as 2 5/8 inches. Further, we can now use this data to answer additional questions as needed. The objective of this lesson was to represent data on a line plot. We met this objective by first identifying the parts of a line plot, then we created our own line plot using collected data.